Suppose that dozen A cakes require 3 kilograms of flour, 1 kilogram of sugar, and 1 kilogram of butter. Whereas 1 dozen B cake requires 6 kilograms of flour, 0.5 kilograms of sugar, and 1 kilogram of butter. Suppose that the profit function from 1 dozen A cakes is 20 and 1 dozen B cakes is 30. How many cakes? How many dozen A cakes, which is x1, and dozen B, which is x2, to maximize the baker's profit? So, first of all, the flour constraint, which I wrote here, the profit function is this 20. Suppose that the profit from dozen A cake is 20. So dozen A cakes, which is x1, 20 x1, and dozen B cake is 30 plus 30 x2 will maximize the baker's profit. So now we know that this is the profit function. So the constraint, you are maximizing this. You are maximizing the profit function. Maximizing the profit function. Subject to ST, this is subject to. How many flours does A cake have? 3. So we have 3 x1, 1 kilograms of sugar, and 1 kilograms of butter. So how many flour does a B cake have? That is 6 plus 6x2. And what are you maximizing is, what is the maximum? 150 grams of flour, because that's what they have. So if it's maximum, that's less than or equals to 150. Because you're maximizing it towards 150. You're not making it more than 150. So this is for flour constraint. Flour constraint. So for butter constraint, how many kilograms of butter does an A cake have? 1. x1 plus 0.5 x2 less than or equals to 22. Sugar. And the last one, which is butter, it has 1 kilogram of butter plus how many kilogram of butter for the CB cake? Another 1 kilogram, less than or equals to 27.5. This is butter. So now this is our profit function, 20x1 plus 30x2. This is the constraint. So now I'm going to equate the constraint. That is the next step. You equate the constraint. After you get the objective function, you get the constraint. Then you equate the constraint. Then you now solve it in a simultaneous equation. Good. Pen. So, as I said that time, 3x1 plus 6x2 x2 less than, equals to, now that we are equating it, equals to 150, equation 1, equation 1. So the next one, x1 plus 0.5 x2 equals to 22. This is equation 2. And the third, x1 plus x2 equals to 27.5, equation 3. Now I'm going to use equation 1 to substitute equation 2. x1 equals to 27.5 0.5 minus x2. And let me substitute it into equation 2. 27.5 minus x2 plus 0.5 x2 equals to 22. Equation 3. Equation 4. So I'm substituting equation 4 into equation 2. So 27.5 minus 1 minus 0.5, that's minus 0.5 x2 equals to 22. Minus 0.5 x2 equals 22 minus 27.5, that is 5.5. Minus 5.5. Now I'm going to divide both sides by minus 0.5. Divide through by minus 0.5. That will give you x2. If we divide it, we know that we get 11. That's 11. So now I've gotten 11. Note that I'm going to substitute 11 into equation 2 to get my x1. So into equation 4 to get my x1. But this, since my x1 is since my x1 is 27.5 minus x2. So therefore, my x1 will be 27.5 minus 5, sorry, minus 11. 11, that is 16.5. So the first set of variables that x1 will give us and x2 will give us, that will be 16.5 and 11. But we can't have 16.5 flowers. So we can't have 16.5 dozen a cake. So we can also say 1711. So now that I've gotten this one, let's get the other two of them, the other two variables. There was another one. If you wrote what I wrote down, that give us 3x1 plus 6x2 equals to 150. X1 plus x2 equals to 22. Sorry, plus 0.5 plus 0.5 x2 equals to 22. Since I've used this one already, now let me equate this one to the nearest to make x1 the product of the formula. That is minus 0.5 x2. Now equate this into this. That is 3 into bracket 22 minus 0.5 x2 plus 6x2 equals to 150. 3 times 22 is 66. 3 times 0.5. That's 1.5. So minus 1.5 plus 6x, that's 4.5 x2. Equate this, 150 minus 66, that will give me 84. So divide everything both sides by 4.5. So therefore, yeah, x2 18.667. So now that we know x2, let's use this to find x1. Don't forget the first one, 16.511. The second one, now I want to use this to get x1. So x1 is equals to 22 minus 0.5 x1 times 18.667. If you do it, what you will get is 22 minus 0.5 times 18.667. That's 12.67. 12.67. So another one gave me that's 12.67, 18.67. That's another dozen A cake and dozen B cake. So the first one, notice 16.5, 11, 12.67 and 18.67. So now I want to use this to get x1. So x1 is equals to 22 minus 0.5 x1 times 18.667. If you do it, what you will get is 22 minus 0.5 times 18.667. That's 12.67. Sorry, 12.67. So another one gave me that's 12.67, 18.67. That's another dozen A cake and dozen B cake. So the first one, notice 16.5, 11, 12.67 and 18.67. So I'm going to do the third, and okay. So if you observe, I've always been to two equations. So the way I'm going to solve it is that within those three equations, I will make sure I pick two. If I pick equation 1 and equation 2 before, I won't also pick equation 2 and 3. Or if I've used equation 3 as the subject of the formula before, I will I will use equation 2 as the subject of the formula, and I will not link it to equation 1. Like it doesn't have to link at all. So since I've used this equation 3 as the subject of the formula before, I won't use it again here. I'm going to use the first one. So this is what I'm going to do. I've made this one the subject of the formula. 3x1 equals to 150 minus 6x2. x1 150 minus 6x2 over 3x over 3. So now I'm going to equate to this into the equation now. Or I can simply just use elimination method. That's true. Let me use elimination method instead. Multiply by 1, multiply by 3. 3x1 plus 6x2 equals to 150. 3x1 plus 3x2 equals to 27.5 times 3 is 2.5. Now minus everything. Dot 3x2 150 minus is 2.5. That is 67.5 divided by 3, 22.5. X2 22.5. Now since x 22.5, I'm going to equate this into this equation. So x1 plus 22.5 equals 27.5. So therefore x1 That's 27.5 minus 22.5. That is, if you bring this here, you will get 27.5 minus 22.5. That will give you 5. So the third one, that is 5, 22.5. So now so if you wrote everything down, you remember the first one I got was 16.5, 11, 12.67, and 18.667. I also had 5 and 22.5. So the way this is done is that this is does it this is x1, x2, whereby all this is does an a cakes, all this does a b cake. So to get my profit function, if you recall, my profit function here was 20 a cakes. Since a is x1, 20 x1 plus 30 does b cakes. That's 30 x2. So I'm going to equate each of this here. So it's a calculator. If you do everything, equate, put this into this. See, this is also, since this is x1 and this is x2. 660. This one will give you 6. This one will give me 813.35. And if you equate this one into this, 775. This will give me 775. So to get how much does a cakes and does a big cake that will maximize the baker's profits, normally it's meant to be 813.35, but this requirement, this exactly, it doesn't fit what you use to get the constraint. So I'm going to use 775 because this is the best answer, or this is the best value that I will get to maximize the baker's profit. You know that LP has a graph. LP has a graph. So if you do your graph and you eventually do 16.1, 11, you get something like this. You do the other one, you get something like this. And this one is like outside the visible region. You won't use it to get the visible region. The visible region is something like this. This is your LP. This is one, this is one, this is one. This is the visible region. This region inside. I'm going to show everything outside. Show everything outside. Show everything outside. So this is the visible region. So therefore, the baker will need 5 dozen. Mind me, sorry for this. The baker will need 5 dozen A cakes, and you can't obviously get 22.5 dozen B cake and 23 dozen B cakes. Simple.